Hi all, today's topic is two-dimensional random variable. Two-dimensional random variable for a third unit. It is divided into two types. Already we know that it is nothing but discrete random variable and continuous random variable. These are the topics to be covered in this unit. Marginal distribution, conditional distribution, and covariance and correlation, regression, central limit theorem. So the marginal distribution, conditional distribution, covariance and correlation and regression. First four types. It is for a discrete and it is for a continuous. So central limit theorem also it is a different. Okay, it is discrete and continuous both. It is the same only single model. So what is two-dimensional random variable? The definition for two-dimensional random variable, if X is a sample space associated with a random experiment E, then X and Y be a two random variable defined on the sample space, then the pair X comma Y is called as a two-dimensional random variable. How we write? Already we will write P of X. So only one variable we are familiar in writing. It may be a P of X or it may be a F of X. This is for a discrete and this is for a continuous. This is discrete. This is continuous. Till now, first unit and second unit we followed with both this notation only. Now in this unit fully we are going to write two variable. Probability of X comma Y and F of X comma Y. Two variable we are going to write. That is called as a two-dimensional random variable. Example is measurement of height and weight of a student in a classroom. Height and weight. So two cases X and Y. Okay. So the two-dimensional discrete random variable and two-dimensional continuous random variable. Two cases are there. So discrete random variable, what is the definition means? If a set of all the values of x comma y is finite or countably infinite. For example, when we toss a coin twice, what are all the output we will be getting when we toss a coin? Already the sample space I have written. So this is the output we will be getting. So this is called output. Okay, so when twice means head tail head and tail so how we will be using x and y for a discrete means x is nothing but number of the heads obtained in the first toss. Okay, so y is nothing but number of the heads obtained in the second toss. So it can be any option. For example, so according to this, so head at the first time head I may get first time head. Okay, so only in this both 1 1 remaining I am not getting, so it is considered to be 0 only. So why what I am considering number of the heads obtained in the second toss. Okay, second toss means second parameter. This is head. Okay, so this is head second toss. Okay, so though both 1 remaining everything 0. So this is the way we will be writing a discrete random variable for a two dimension. Okay, so in this there are so many topics, three topics. So joint probability mass function, marginal probability distribution, marginal probability function, and conditional probability function. Three topics we have to know about each discrete and continuous. Okay. So joint probability mass function means how we write both. We write it like a probability of x comma y. You write it probability of x comma y. It's called as a joint probability mass function. This mass function for a discrete we tell it is a probability mass function. It is nothing but PMF. Okay. So probability of xi comma yj equal to probability of x equal to x and y equal to y. So these two conditions are satisfied only, then I can go with any probability. This is general condition. You need not check. Okay. So probability of xi comma yj greater than or equal to 0 for all I and j equal to 1, 2, 3, etc. Sum of two summations, sum of I and sum of j, probability of xi and yj equal to 1. It is for this we will be using for calculating k or any constant. Okay, to find out constant we will be using this formula. Okay, then only I can find out the constant. Some double summation probability of xi and comma yj equal to 1. Okay, this is why I and j are written, means for generalized case you get a confusion, means we have to write it this way, probability of x comma y. Okay, so same way the second topic is marginal probability function. It is two types, marginal probability function of x and marginal probability function of y. P of x, okay, P of x is nothing but summation over j probability of xi comma yj. P of y is nothing but summation over probability of xi comma yj. So next topic is conditional probability function. In this also we have a two set of formulas. Already conditional we have studied in the first unit. Probability of A given B equal to probability of A intersection B divided by P of B. The same concept we write it in a variable of X and Y. Probability of X given Y equal to probability of X comma Y divided by P of Y. Probability of Y given X equal to probability of X comma Y divided by P of X. So conditional probability. Independent means when x and y are independent given, then I can multiply both. Probability of x comma y equal to p of x into p of y. Same way it is for expectation also. It may be a plus or it may be a into dot product. Okay, into. So both it is satisfied. So e of x plus y equal to e of x plus e of y. E of x into y equal to e of x into e of y. So completed. Till now it is the only for a discrete random variable. Now same concept, you come with a two-dimensional continuous random variable. So if value of x comma y is uncountably infinite set, okay, if the ranges are given, it is a continuous random variable. For example, if a set of x comma y where x plus y squared equal to 1 is a range space of x comma y is the example. So same concept, we have a three set of formulas. Joint probability density function. So in this we will be writing f of x comma y. F of x comma y greater than or equal to 0 for all x comma y in R real line. So double integration over f of x comma y dx into dy equal to 1. This is this formula you will be using for finding a constant. To find out constant, we will be using this formula. So marginal probability density function in these two types, marginal density function of x and marginal density function of y. F of x is nothing but integral over y, f of x comma y dy. F of y equal to integral over f of x comma y into dx. Conditional probability, same way, two concept. F of x given y equal to f of x comma y divided by fy. F of y given x equal to f of x comma y divided by f of x. Same way, when it is independent, I can multiply both and write f of x comma y equal to f of x into f of y. This is for a discrete. It is a different topic. This is for a continuous. Cumulative distribution function, same thing. We have learned this in the first unit. Same concept. Capital F of x comma y equal to double summation over probability of xi comma yj. Remember, in the upper limit, it's not with infinity. It's with respect to x and y. Same way here, double integration over f of x comma y dy dx. Upper limit is fixed variable. This yellow color, you should not change a variable as it is. The formula is as it is. You should not change it for a cumulative distribution function. So in the distribution function, we have some properties. I have written 7 properties. So the distribution function, this capital F will be between 0 to 1. And f of minus infinity to minus infinity to y, x to infinity, all are 0. Only when both are infinity, x and y are infinity, it is 1. Okay. So I can write this 4th, 5th and 6th is like a formula case. When a is less than x is less than b and y is general limit, y is less than or equal to y, then I can write it with a distribution f of b comma y minus f of a comma y. Same way, when x is less than or equal to x, but c is less than y is less than d, I can write it as f of x comma d minus f of x comma c. When both are with respect to a is less than x is less than or equal to b, c is less than x, y is less than or equal to d, then I can write this first case I can write as f of b comma d minus f of a comma d. Okay, same way, second case I will write a comma c minus f of b comma c. Last formula is when I differentiate with respect to x and y is called the capital distribution function. When I differentiate with respect to x and y, I will get my small f of x. Small f of x is nothing but probability density function. This is nothing but probability PDF of a continuous function. My next topic will be covariance. Covariance, when we say it is a covariance, means when x and y be a two-dimensional variable, defined on the sample space, then I can write a covariance of x comma y equal to E of xy minus E of x into E of y. In this also, if x and y are independent, then covariance is 0. What is between variance? Already we have studied variance and covariance. What is the relation when I connect it both? Okay. So it is nothing but variance of x plus y equal to variance of x plus variance of y plus 2 times of covariance of x comma y. It is the relation between variance and covariance. Next topic will be a correlation. Two variable x and y are said to be a correlator if the change in the value of one of the variable cause a change in the value of the other variable. It's called as a correlation. Correlation is denoted by the symbol R of x comma y. Correlation, we tell another name, it's the coefficient of correlation, or another name, Carl Pearson correlation coefficient. This is the author name. Carl Pearson only derived this correlation. So his name only. Start with his name. Okay, Carl Pearson correlation coefficient. So the formula is covariance of x comma y divided by sigma x sigma y. Okay, so sigma x not equal to 0 and sigma y not equal to 0. So covariance, we know the formula covariance here. I will write again one more time. I will write so that you will not get confusion in this. Covariance of x comma y, the formula x comma y is nothing but E of xy minus E of x into E of y. So sigma x is nothing but standard deviation. What is the formula means? Square root of E of x squared minus E of x the whole square. Sigma y is nothing but same thing, square root of E of y squared minus E of x, sorry, E of y the whole square. E of y the whole square. So completed. Substitute all the three calculated. Substitute in this, we will get R of x comma y. We have some like a property or some note. Okay, if x and y are independent, covariance is 0. Covariance 0 means, here 0 means R also 0. R is nothing but correlation coefficient also 0. So this correlation coefficient, always my answer will be in between minus 1 to 1. That you have to remember it. Minus 1 to more than 1 you will not get. Okay. So minus 1 to 1 only our answer will be. Correlation coefficient is unaffected by changing of the scale, origin and scale. When I change the parameter, instead of x some u, instead of x I change with respect to some condition, change it to u. Instead of y I change it to v. Okay, when I change the parameter, origin and scale, when I change it, it will not be affected at all. Okay, there will be no change at all. So as it is, we can do it. We can change and do. That is the one of the note. Okay. So next topic will be a regression line. Regression is a study of a relation between the variable. When there is a linear relation suggested by a scatter diagram, then this line is called as a line of regression. For example, some diagram you have. Scatter line means some dot. Okay, so this is called scatter line. So that line, whatever, when I join this line, it's called as a line of the regression. We have two types in this. Y on x, my first equation, x on y is my second equation. Regression equation, y on x, and regression equation, x on y. For this, we have a formula. It is nothing but y minus y bar equal to r into sigma y sigma x into x minus x bar, where r is nothing but correlation coefficient. Now only we have calculated on that correlation coefficient. Correlation coefficient is r. In correlation coefficient only, we have studied the formula sigma x sigma y, that we can calculate. X bar and y bar is the x bar is mean of x and y bar is the mean of y. Same way, x on y is nothing but x minus x bar equal to r into sigma x by sigma y, y minus y bar. So this is called as a regression line. But this is a short form. Regression coefficient they asked to find. Okay, this is called coefficient. Okay, this is called coefficient. This they asked to calculate means it is nothing but bxy is nothing but y on x, r into which is first, that sigma y divided by sigma x. Bxy is nothing but r into sigma x divided by sigma y. bxy, it can be in another format. This is r. Okay, so it is nothing. If this is not given, instead of that x and y only given means I can calculate also. 1 by n sum of xy minus x bar y bar divided by 1 by n sum of x square minus x bar the whole square. Same way, b of xy is nothing but 1 by n sum of xy minus x bar y bar divided by 1 by n sum of y square minus y bar the whole square. So properties, we have only one property, regression coefficient. The correlation coefficient between x and y is the geometric mean of the regression coefficient. Okay, correlation and the regression. What is the relation if they ask? Okay, it is the geometric mean of the regression coefficient. This is the last topic, central limit theorem. So what is the definition for a central limit theorem? If x1, x2, etc. x1 is the sequence of n independent, it will be independent, identically distributed random variable, each having mean to be mu and variance to be sigma square, then if x bar, okay, mean I am going to write x1, x2, etc. xn divided by n when I divide it, then variate is nothing but z equal to x bar minus mu divided by sigma divided by root n. This where we have seen, you remember this concept? We have seen this in a normal distribution. Remember, z equal to x bar minus mu divided by standard deviation only we write. Okay, but here by divided by root n, only that will be a change. Okay, it is called, and has a distribution that approaches the standard normal distribution as n tending to infinity, provides the moment generating. This is moment generating function. This is moment generating function will exist. Moment generating function exists. So in the problem wise means this only we will be doing. X bar is nothing but 1 by n, x1 plus etc. xn we will calculate. Expectation of x bar is nothing but mu. Variance of x bar is sigma square divided by n. Okay, square this. Denominator is square, that is called variance. This is standard deviation. This fully is called standard deviation. Okay, variance you need means sigma square divided by n. So that is only variance. Okay. X bar follows with the normal distribution of mean and variance. Okay, mean and variance as n tending to infinity. So that is why we write it n is nothing but mean as it is, variance is sigma square divided by n. Okay, sigma divided by n, mu and standard deviation. Mu and standard deviation. This is sigma. Sigma divided by root n. I have given in this all the formulas related to all the topics with respect to the formula and definition I have given. So my next video will be each topic with the problem only we will be seeing the concept. Thank you.